All right, so let's talk about, first of all, what a matrix, because matrices is the what? The plural of what? Matrix. Oops, forgot to do this. Man, it's been a long time since I forgot to do that. All right, now it should work. All right, so the word is matrix. And, everybody knows the movie and all that kind of stuff, all right? But basically, matrix is a rectangular array of terms, and those terms inside the matrix are called elements. So I'm not concerned that you know the definition or anything, but it's a rectangular, right? Rectangular array, meaning just the numbers are all put together in a rectangle, and each of the numbers in that rectangle is called an element. And they use the letters M. It's not times. That's actually by. Like, you ever go to the lumber store or something, you get a 2x4. What does that mean, 2x4? 2 inches times 4 inches, right? One side is 2 inches, the other is 4 inches. To tell you the truth, if you go and get a 2x4, it's really not a 2x4. It's like a 1 and something, 1 and 7/8 or something like that. It's not even a 2x4, but that's what they call it, just to make it easy. They call it M by N, all right? But the M I'll probably refer to as the rows, and the N is the columns. So if we have a rectangle, array of numbers, we're going to have rows and columns. So I would call it, and I wouldn't really say this, but it's an M by N, R by C, however you want to say it. So rows and columns, all right? That's how we're going to refer to these. So if you wanted to describe a certain rectangle, you're going to describe it by how many rows it has and how many columns it has. So, for instance, let's do this. Let's put some actual numbers in here. What if I had a 2x2 matrix? All right. What I'm going to do, I'm not going to put actual numbers in here. I'm going to put variables. All right. And let's push this over a little bit so I have a little more room to work with. Okay. These are our rows, and I'll tell you what, let's move this down here so I have room to write up here, and these right here would be my columns. So let's call this A. Since there's going to be more than one A, we'll call that A1 and A2. This is the way they do it in the books. This is how I'm going to do it right here, B1 and B2. All right, so these represent numbers. We're going to eventually, very soon, put actual numbers in here. Okay, they could be fractions, they could be decimals. Most of the time we'll work with integers when we're first learning how to do this stuff. They could be variables as well, okay, because variables represent a number. So these are rows and these are our columns. So that's why it's a 2x2. There's 2 rows, 2 columns. It's hard to tell which one's which, but rows always goes first, columns always go second. I always remember that because of, I don't know if this is a soda that is, it's on the shelves, but usually they're really dusty because nobody drinks them. But when I was a kid, I used to drink them all the time. Anybody know what I'm talking about? An RC Cola, right? Anybody drink RC Cola? All right, it's good. It's actually got a little different flavor than Pepsi and Coke does. I grew up drinking RC Colas. We would go to the gas station, and they would sell them in glass bottles. And the glass bottles were put in like a wooden crate, and it was kind of like a matrix. And they had a little square, right, that you'd put them in. And then you'd drink them, and you'd actually go back, and you get money back when you return the bottles. And that was always kind of nice. And so I used to go ride my bike to the gas station down by my house, and I'd get a new crate, I guess, of RC Colas. But RC Cola is how I remember this. Rows, then columns, all right? So the first one is the row, and the second one is the column. Of course, a 2x2 or a 3x3, it's hard to tell which one's which, but there we go. So what if you had like a 2x5 matrix? Let's put this up here. 2x5 matrix. What is that? How many rows does it have? It's got 2. And how many columns does it have? 5. So this would be A1, and this would be what? A2. All right. So there's your rows. And, oh, by the way, we put these little brackets on there to kind of keep everything together. All right. So that's what we usually use for a matrix. All right. And this would be B, C, D, and E. This would be B, C, D, and E. But we would put 1. So our first row, put a 2 for our second row, all right? And again, this is the way the book does it, so that's how I'll do it. So that's a 2 by 5. Everybody with me? All right, what's a 3 by 1 look like? 3 what? 3 rows and 1 column. Good. So that would be A, and A. That'd be A1, A2, A3. We put it with the brackets around it, and that's a 3 by 1. See, there's 3 rows, but there's only what? 1 column. Everybody good with that? And we're going to refer to that. We're going to refer to that quite often, so it's good to know what that means. What if you had equal matrices? Equal matrices, they have the same dimensions, and they would be equal to each other. So if I had like a 2 by 2 matrix, so let's put some numbers in. I'm just making this up. All right, so what if we had a matrix like this? And what if I said another matrix was equal to this matrix? Then they would have the same exact things inside them, okay? The same dimensions, right? 2 by 2, and the same numbers in the same place. These would be equal matrices. All right, not hard to figure out, but I thought I'd throw that in there. All right, so now what we're going to do, let's do an example. I think I must have skipped example 1. So this is example 2 in the book. It says find the values. I'll just say find x and y. All right, it's pretty easy. So they put the y up top and the x on the bottom. So that's what's the dimensions of this matrix right here? 2 by 1, right? So 2 by 1, and they say that's equal to. Now remember, if they're equal to each other, the other matrix has to be a 2 by 1 as well. All right, and it is. And they put, remember I said they could be numbers or variables inside of a matrix. All right, so this is how they write it. It's not real practical, I mean, right now, but later on we're going to be doing things that could be very practical. And but this is just kind of getting us to understand what that means. So what does this mean? So this one is in the, first row, right? And they're all 1 column, but this is in the first row. What's in the first row over here? Which ones match up with each other? Well, of course, those two match up with each other. So it means those elements are going to be equal to each other, just like this. See how it's in the top left? That's in the top left. They're equal to each other. They're the same. Everybody got that? So these are equal to each other. So if I wanted to solve for x and y, what could I write? How could I write this down? Y what? Equals 2x minus 6. Good. And then what does this mean right here? X equals 2y. And now you just do some math and you just solve for x and y. Tell you what, just for the sake of time, I'll let you do that on your own. X is 4, y is 2. And I think they just leave the answer like that by circling them. Okay? And that would be your answer for x and y, because that's what it says. It just says find x and y. That's easy, super easy. All right? It's just introduction stuff for right now. But now we're going to do stuff here in a second. Again, it's not that hard to see, but let's do this. A lot of times they name the matrix, and they name it with a capital letter. So here's just some random matrix. We're not really doing anything with it right now, but we name it with a capital letter. All right, so that would be matrix A. All right, what if I wanted to add matrices? It's very simple. I should put add or what? Subtract. It's kind of the same thing. All right, so add or subtract matrices. Again, they've got to be, in order to add or subtract matrices, they have to be the same dimensions. All right, I can't take a 2 by 2 and add it to a 3 by 1. Everybody understand that? So if you got a 2 by 2, you can only add it to another 2 by 2. This one is a 2 by 3 that we're going to do right now. And it says, I'll just scooch this out of the way. So it says, find A plus B. Well, what did we just say these represent? These capital letters representing what? A matrix, right? Okay. But now, I don't know what A and B is, but they tell us what it is. So they tell you A is, and let's just write this down, negative 2, 0, 1. First row, and then 0, 5, negative 8. All right. And then B Again, it's going to be the same dimensions, but it's -6. This should be very intuitive, right? Without even knowing anything about matrices, just the stuff that I've told you up to this point, I bet you anything that you could figure this out on your own. Would you agree? Yeah. So I'm going to add them up. Again, just because of time, I'm not going to show this plus this. Well, maybe I can. I can do it kind of quick with this. All right, so there's that. There we go. That's a lot faster than... There we go. It's a lot faster than just writing them down. So if I put a plus right there, this is A, correct? Matrix A, and this is matrix B, and I'm adding them together. So what do you think you do? It's not brain surgery here. Very simple. What do you do to those? Just add the ones up in the same place, right? So let's do it in our head. In my notes, I wrote -2 plus -6, but let's just do that in our head. All right, so what is -2 plus -6? It's -8, so that goes, see, that's the top left one, right? First row, first column, right? Let's go across that row. So it's 0 plus what? 7, which is 7. Don't put any commas or anything, just leave a little gap between. Don't put it right next to each other where it looks like a -87. Leave a little gap so you know that they are individual numbers. Let's do the top. What else do you have? 0. Now the bottom row, what is it? 4, and then the next one, 2, and then the next one, 2. Good. And that's it. That's how you add matrices. Very simple. They give you example 4. That was example 3. They give you example 4, and they ask you to subtract them. All right? So let's just do the same one, all right, without me writing everything down again. Let's do that same one, but let's subtract instead of add. I feel like I could almost skip this, and I probably could, but we're going to do it anyway since we're here. So you got to be careful, though. Here's what the book does. The book always takes that subtraction and makes it an addition. And that's an okay way to do it. You want to do it that way? So watch. Instead of subtraction, we make it what? Addition. But we add what? What do we have to do to these? Change all the signs, right? So change that one, that one, that one, there, and there. And now you just add them, okay? -2 plus 6, 4, and so on. I'm not going to do the rest. I think you got that figured out. Am I right on that? Okay.
Well, we don't have to do
What's that? The plus thing? No, you could have just subtracted. But sometimes subtracting, because you would like subtract a negative, right? You got to remember it's a plus. And sometimes that does get a little confusing. But yeah, you could just plain old subtract if you wanted to. It's perfectly fine. All right, let's introduce another word to you. We really haven't learned anything deep about a matrix just yet, okay? Once we start getting into multiplication, that's where... Do you remember doing this at all in Algebra 2, multiplying matrices? I don't know. That's all right. It's no big deal. Now, if you multiply by just a regular number, it's pretty easy. It's very easy. Again, it's very intuitive. You could just look at it and say, oh, yeah, I know how to do that. So we call a regular number, okay, that's being multiplied by a matrix, we give it a special name. We call it scalar, S-C-A-L-A-R. Have you heard of that word before? Okay, it's called a scalar. When you take physics, you'll talk about things that are vectors and things that are scalars. So you will see that word again at some other point. Can somebody open that door for me? Oh, it's already open. Okay, so we call this a scalar product. So here's what it is. They use the letter K to represent a scalar. That's a lowercase k, did you notice? Looks like a lowercase k, supposed to. And then A. So what is the A? It's a capital letter. So what am I doing? I'm multiplying a what? A scalar times a what? Anybody talking to me today? You mad at me? Okay, a matrix, right? It's 1, so it's a matrix. So this is a scalar times a matrix. Very, very simple to multiply a scalar times a matrix. So, all right, they say find. This is one of the examples. This is example 5. It's in the book under example 5. It says find 3a, all right? Now, what do you think they're going to give you? They're going to give you the matrix A, right? And they make it obnoxiously big, but that's okay. We'll write it out. 1, -1, 3, 7, 0, -3, negative 1, 8. All right. That's matrix A. Now, if I was going to multiply 3 by this, then I just stick a 3 outside of there. Again, this should be very intuitive. You know what that means, intuitive? You can just kind of, not really easy. Yeah, but you kind of look at it and go, yeah, that makes sense. I think I could figure that out on my own, right? That's what intuitive means, basically, in this case anyway. So, it's going to be the same dimensions. Nothing's going to change as far as the dimensions are concerned. But what are we doing to every element inside this matrix? Just multiplying everything by 3. So that's all it is. So that's kind of almost a waste of time, but we'll do it anyway. So that's negative 3. This is what? 9. That's 21. That's 0. That's negative 9. That's negative 3. And that's 24. There we go. We multiplied by a scalar. Very easy. Now, this is what you came for today, all right? How to multiply matrices. Now, the matrices in multiplication do not have to be the same dimensions, okay? So we are multiplying, multiplication, if I can spell it right, multiplication of matrices, all right? Kind of like to label each little section that I do here. Right? So we are going to multiply them together. So first of all, you have to realize you cannot multiply any dimensions of matrices together. Okay? They have to fit a certain pattern. Everybody hear me? They don't necessarily have to be the same dimensions. Now, there are some times where you can have the same dimension, but let me show you what has to be true. So if I had a 2 by 3, they give you this big, long description of this, and it gets really confusing. When I took my notes on it, I'm like, I got to make this a little bit easier. So this is what I did. So make you understand. So what if I had a 2 by 3 matrix, and I want to multiply it, okay, by a 3 by 2 matrix? First of all, you got to look at it. I'm going to show you what you have to look for in a second. But if I just give you the dimensions of the matrix, you should be able to tell me, yes, I can multiply those together, or what? No, I can't multiply them together. On this one, I can multiply them together. And I can also see what the dimensions of my answer are going to be. All right? This is a 2 by 3. This is a 3 by 2. It doesn't mean my answer is going to be a 2 by 3 or a 3 by 2. All right? Let me show you how we do it. It's very simple. Okay, if you put them next to each other like this, see the 2 in the middle? If they're the same, so if the columns of the first matrix is the same as the rows of the second matrix, then we can multiply them together. All right, everybody see that? So if these numbers are the same, then yes, we can multiply them together. So what's the dimensions of my answer going to be, though? Well, this tells you as well. See the numbers that are left on the end? That's going to give you the dimensions of the matrix. So it's going to be a 2 by 2, right? So your answer is going to be a 2 by 2 matrix. I mean, that's not the answer to the question, okay, because they're going to have matrices, they're going to be numbers, we're going to do some multiplication and all that stuff. So first of all, you have to determine, am I able to multiply these to begin with? Always look to see that. So you put them next to each other, and yes, you can, all right? And then you can also see what the answer is going to be. It's going to be a 2 by 2 matrix for my answer. Let's try another set of matrices. What if I had a 3 by 4 and I was multiplying it by another 3 by 4?
When the bell rings with the juniors, please go to room 206 for a prom meeting. Thank you.
Look at this. Can you multiply a 3 by 4 times a 3 by 4? You cannot, because if you take a look at the 2 that are inside, they are not the same. So no, you cannot multiply them together. All right? That's pretty easy, isn't it? They make it kind of complicated. If you look in the book and see their explanation for it and all the letterings and stuff they use, it's a little bit complicated. But that's really what you have to know to be able to do that. All right, everybody good? All right, flip around. You ready to do your first multiplication? This is where the real stuff happens, right here, okay, with the multiplication. I haven't done these in many, many years. It's been a long time since I taught this. And I used to teach it all the time. But it started coming back to me. I'm like, oh, okay, now I'm remembering this now. It's good stuff. All right, so here we go. I'm going to they give you 3 matrices. This is example 6 in the book, if you want to look in the book. They give you A, B, and C matrix. So A is 7, 0, 5, 3. Write these down. Matrix B is 3, negative 3, 6, 5, 4, negative 2. All right, and then matrix C, 6, negative 1, 4, and 2, negative 2, 1. Negative 1, sorry. All right. So they're going to ask you to multiply a couple combinations of these matrices. All right, so here it's, part A, B, and C. Now, one of them is not going to work, right? So really, we only have to do 2. And I think they don't even give you the third one. I think I made up the third one myself, okay? They just give you the 2. But I think it's good for the extra practice to do the third one. So they say, for this one, they say find, and here's how they do it. They just put find AB. What does that mean to you? Yeah, it means you multiply matrix A to matrix B. Everybody with me on that? So I'm going to write them down. Well, I'm going to copy and paste them. The times, I'm just going to put a little dot right there for times. And then I'm going to multiply it by this matrix. If I can. So I got to figure out if I can multiply these together. Don't start trying to multiply and then halfway through figure out, wait a minute, I'm stuck here. There's no way I can do this. Make sure that you figure out if you can multiply them or not. What's the dimensions of this first matrix? It's 2 by 2. We're going to multiply it by a what? A 2 by 3. So can I? Yes, because look, if those two numbers are the same in the middle like that, yes. All that tells me is yes, I can multiply them together. All right. Remember, the columns, the number of columns has to be the same as the number of rows. Is that correct? Yeah. 2 columns, 2 rows. Yes, I can multiply them together. Everybody good? Got that? Now, what's my final answer? What's the dimensions of my final answer going to be? It's going to be a 2 by what? 3. All right, because of this and this. So that's easy to figure out, right? Now, here's where it gets a little bit complicated. It used to be I would do this on the board, and I'd use my fingers. I'd go across and down like this, and that really worked out nice. So I'm going to try to figure out how to do this on this tablet right here. As soon as I sneeze, give me a second. Maybe I can hold it in. All right, I think I'm good. All right. So what we're going to do is this. I'm just going to show you in the example how to do this. So let me make sure I get this right. So what we're going to do is we are going to multiply across this way. Well, we're going to multiply, then we're going to add. All right, so there's addition to this as well. And then we're going to go down like this. Everybody see that? You remember doing this last year at all? Okay, so you go across and down, and then you're going to go across again, then down, across again, then down. Got it? And then, right, then you do it to the bottom row, and then you multiply these times these, this one, this one, this one, this one. Okay? All right, so let's do this first. I'll get rid of the yellow when we're doing these. So let me give myself some room. Let's push this up a little bit. And yeah, let's do it here. All right, so what I'm going to do is I'm going 7 times 3. All right, see how that's in the same spot right there? Well, kind of, right? Because I got 2 here, right? Everybody see that? So the 7 times the 3. And then I move over to the 0. I'm going to add 0 times, what do you think? Times the 5. 0 times 5. Everybody with me? All right, so that's, remember, this is a 2 by 3, right? So that's the first element, right, in the thing, in the matrix. All right? Oh, I'm looking at the wrong number. I was like, woo, that's not right. Thank you. All right, let's do the next one. So now, let's do this one. So all I do is just move over to here. Now what am I going to do? 7 times what? Whoops, let's go back to white. I want to stay color coordinated here. So yeah, so now I'm going to go 7 times -3 plus, talk to me, 0 times 4. Good. Everybody got that? All right, let's move this over. Now I'm going to go 7 times what? 7 times 6 plus 0 times -2. Thank you. Yes. All right. So we've done that. Now we got one more row to do. So guess what we're going to do now? Take this, drop it down to here. We're going to take this. Yeah, this is working out pretty good, I think. Then we're going to do this. Now we drop down, okay, to the bottom left since we're starting down here. Now what do you think you're going to do? 5 times what? 5 times 3 plus 3 times 5. Right? I took this one times this one. Then I went this one times this one. Now I do it to the second column. Yes. Okay. All right, now what do I do? 5 times -3 plus 3 times 4. Got one more to do. You getting the hang of it? Yeah. Just takes a few minutes to kind of get used to the pattern, right? Once you see that pattern, and it's not really difficult to do if you see the pattern. Now what do we do? 5 times 6 plus 3 times -2. Good. And that's all in a matrix, right? Just like that. And now, obviously, what do you think we're going to do this? Yeah, just going to add them up, multiply them, add them up. Can we do this in our head? Probably. Let's do it. 21 plus 0 is 21. What's this? -21 plus 0 is negative. Thank goodness for the zeros, right? What's this? 42 plus 0 is 42. Not going to always be that easy because they're not always going to have zeros. 15 plus 15, that's not hard. That's 30. -15 plus 12, -3. 30 plus -6, or 30 minus 6, which is 24. And there you go. You just multiplied. Well, it's not your first one because you did this last year, but at least in here, it's your first multiplication of matrices. And there you go. And that's pretty much it. I can't believe I finished this in one class period. And it's shortened day, too. So get your homework done. It's section 2-3. If you guys were taking the quiz, obviously, what do you do tonight? Watch the video. This one right here? Sure. Why not? Okay. Well, I trust you to do what you need to do. There it is right there. Okay, there's your homework. And that's due tomorrow.